Hey guys, welcome back to the channel. In a previous lecture, we discussed about TF-IDF feature extraction techniques along with the implementation and calculation. Now, in today's lecture, we are going to implement sentiment analysis in which we are going to use TF-IDF as a feature extraction techniques and also classify whether a sentence positive or a negative by using one of the classification algorithm. So let's get started. So here we are going to use IMDb review classification dataset in which we are going to classify whether a review is positive or a negative, right? So first of all, I have import pandas library. As you know, pandas library is very useful for importing any kind of data set and also performing various operations on particular data sets, right? So here I have used pandas library and used the alias as a PD. After importing pandas library, I have used the read underscore csv function in pandas library to import our data set. So syntax is pd.read underscore csv and the part of our data set, right? And store the data into df variable. So by using the head function, we display top 5 records of our dataset. So here you can see in our dataset we have two columns, review and sentiment, and in which the review column contains all the reviews of IMDb dataset, and sentiment column we can consider as a label column. It tells whether a review is positive or a negative, right? After that, we need to perform text preprocessing techniques. Here I have used only two text preprocessing techniques, although you can use other text preprocessing techniques as per the requirement. If you haven't watched my text preprocessing videos, you can see or you can watch out in my playlist in which I have explained almost 40 to 50 text preprocessing techniques which can be helpful to you in any kind of NLP projects. So here first of all we convert entire review into the lowercase. So for that we pass the entire review column to apply function. Apply function iterate each review one by one and pass it to the lambda function. And lambda function first of all converted the review into the string and then by using lower function converted entire review into the lower and pass it to the review column, right? After that, as you can see in our dataset, there are a lot of HTML tags are available. So I want to remove that HTML text. For that I have used the regular expression. For that I need to import RE library. So import RE, and after that we pass the entire review to apply function. Apply function iterate one by one and pass it review to the lambda function. After that, by using RE function, we have to make a pattern of HTML tags. If you want to learn lot of patterns for text preprocessing, you can see my text preprocessing video. That will be a very helpful to you to understand this concept. So here this is the pattern of HTML tag, and here in the second parameter we pass the blank, which means if the any HTML text is found, it would be a replace to the blank. And in the last parameter we need to pass our review. So here you can see all the reviews are in a lowercase and also HTML tags is removed, right? After that I want to apply lemmatization. What lemmatization is? I want that all the word or adjective or a noun should be in a root word. For example, here I have put a sentence, I ate apple, right? So first of all I use the word underscore tokenization. What word underscore tokenization is this? It will give output of each word as a separate in a list form, right? So here I got the I as a first index of list, and 8 as a second, and apple is a third. After that, we perform lemmatization. Lemmatization convert all the word into root or a base word, right? So for that you just need to apply a loop in which one by one each word is iterate, and by using lemma.lemmatize we just need to put that word and we got the root or a base word of that particular word, and we just need to append in word list, right? So we got this output after performing the lemmatization. So here you can see the 8 is a past participle of it, so we got the root word of it, and by using the joining function we get the sentence of particular list. Here the list is, and how join function is join all the word of list by using space, right? To use the word tokenization, we need to import word underscore tokenized library, which is placed into the NLTK package, right? So from NLTK import word tokenization, and for lemmatization we need to import word net lemmatizer, which is placed in nltk.steam.wordnet, right? After that we need to make a object of wordnet lemmatizer. After making a object of wordnet lemmatizer, here I have make a list comprehension so that this entire code placed into only one line. After that, we just need to pass entire column to the apply function. Apply function give it each review to lambda function, and lambda function first of all tokenize the sentence and pass each word to the lemmatization. And after that entire process is done, we can join the list of word by using space, and we got the review as a sentence and store it into review underscore pre column, right? So here you can see we got the output of in a review underscore pre column. Now the next step is feature extraction. In a feature extraction we use the TF-IDF vectorizer, right? If you want to know more about TF-IDF, how TF-IDF is work, how TF-IDF is implemented, so for that you go out to the playlist and watch out the TF-IDF video in which I have explained everything in detail about TF-IDF. So here for using a TF-IDF we just need to import TF-IDF vector by using sklearn.feature underscore extraction.text package, right? After that we just need to make an object of TF-IDF vectors and store it into a TF-IDF model, and then we just need to use feed underscore transform function in TF-IDF and pass it the entire pre-processed review. Here these numbers tells us that this particular word in a first sentence is placed this position in a vocabulary, right? And here the probability of TF-IDF vector, right, which means the value of TF-IDF. If you want to see in a proper format, you just need to use toDense function at last so that you get this kind of matrix, or we can say vector, right? Here you can see the vocabulary of entire reviews by using tf-idf.vocabulary underscore. So here you can see the vocabulary of this. You can see like 3671 word, which means you just need to find here 3734 index tells us that the word is date, right? Likewise, you can measure these values. After that, we just need to convert entire this value into the data frame. So for that, we use the pd.data frame, in which we just need to pass this entire format, or we can say syntax. And for the columns, we just use the vocabulary. For the vocabulary, we just need to use TF-IDF model.vocabulary, and we just sorted the columns, right? After that, we just need to print entire TF-IDF df. You can here see the all the vectorized form, or we can say numerical representation of each review, right? Here you can see some unwanted values in our column, so you just need to apply other text preprocessing techniques to remove these kind of unnecessary or unwanted values. Now here you can see our sentiment, or we can say our labels, is in a text format, and as we know, computer doesn't understand the text value, so we have to convert this text label into the numerical label. So for that, we just use the here apply entire sentiments column to apply function and pass it to the lambda function. Lambda function check if x is positive, which means here x is one by one review comes, one by one review is coming, and it checks it is positive. If it is positive, it will convert it, or we can say it will store as a 1, else 0. So here you can see we make a new column label, and in which positive value converted into the 1 and negative value converted into the 0 value, right? After that, we just apply logistic regression algorithm to classify whether a sentiment is positive or a negative. For that, we just need to import logistic regression by using sklearn.linear_model package. After that, we just make an object of logistic regression and pass TF-IDF df, which is our numerical representation, as a input of x, and as a y, or we can say as a label, we just need to pass label column, right, in a feed function, which is helpful for the training, right? After that, for the prediction, we just need to use .predict function and pass the TF-IDF df to get to know our prediction values. So here I have stored the prediction value into predicted_label function, so you can see all the prediction value, right? Here to see the probability of the prediction values, you just need to use predict_proba function, right? So you get to know all the probability values of this particular prediction. Now we just add these predicted labels columns into our main data frame. So here you can see our predicted value and original value is almost same, right? To get to know the accuracy of our model, so you can just need to use cross tab, in which cross tab is nothing but it is very helpful to you how many records are correctly classified and how many are not correctly classified. This method is known as a confusion matrix, which is popular for the evaluation of classification algorithms, right? So here you can see predicted label 0 and 1, and this label is 0 to 1 is original data. So here you can interpret it like this: 0, which means originally is it on a original record it is negative, and predicted also it is negative, so which means 487 is correctly classified. Likewise, predicted is 1 and original also 1, so 486 also correctly classified. However, this 15, which means originally it is positive, but it it is classified as a negative, and like vice versa, like originally 0, which means it is negative but is classified as a positive, so 15 plus 11, which means 26 records are not correctly classified, right? Likewise, we can interpret the confusion matrix. Okay, so that's it for the today's video.